Hi, I'm Carl Cook, president of IntelliDynamics. In oil and gas, you're always balancing three realities. You can't measure everything everywhere. You still have to run the field safely and profitably. And the numbers still have to hold up for engineers, operators, and accounting. That's exactly where virtual flow metering, often called VFM or virtual metering, creates durable value. In real assets, measurement is incomplete by design. Putting meters on every well is expensive to install and maintain. Some measurements simply aren't available where you need them. And even when you do have instruments, sensors drift, foul, fail, or get taken out of service. Meanwhile, the asset changes. New wells come online, water cut shifts, and facility constraints move. But decisions don't stop. Operators and engineers still need trustworthy rates for allocation and production accounting, for surveillance and well and facility performance, and for optimization and planning. So the question isn't whether the data is perfect. The question is whether the numbers are trustworthy enough to run the business on, day after day. A virtual flow meter is a system that produces estimated flow rates, oil, gas, and water, using the measurements you do have and validated models. Two clarifiers matter. First, VFM is not magic AI. It's an operational capability that has to be validated, monitored, and governed. Second, VFM is not just a model. If the estimates don't hold up to scrutiny over time, you don't have VFM. You have a dashboard. Where the AI and machine learning comes in is how we build the models. We use a combinatorial search to find the right sensors as inputs, the right model type, and an automated design that consistently produces high-performing models. Because every well is different, we model each well and each phase individually for accuracy. Then we don't rely on a single model. We use a committee of models for robustness. We then run tens, hundreds, or thousands of managed virtual meter models to fully serve our customers' assets. We treat performance assurance as a requirement, not an afterthought, so the estimates hold up when conditions change. When VFM is deployed as an operational system, the value shows up in a ladder. First, understanding, rates you can trust, and clarity on what's driving performance. Second, prediction. Inform the asset team what they are producing and where. Third, optimization. It's not just better numbers. The models also capture how each well responds to production assist, like lift gas, choke changes, or other operating moves, so you can make constrained decisions with insight into production response, not guesswork. This is why VFM is often an ideal starting point. Once the organization trusts the numbers, you can expand into broader prediction and optimization in a controlled way. In operations, adoption is gated by trust, so validation and sustainment have to be first-class requirements. A practical governance stack includes benchmarks against tests and back-allocated production separators, ongoing monitoring of estimate quality and sensor health, drift detection and adaptation as the process changes, change control and validation, documentation and reporting, and clear ownership so the system doesn't become shelfware. In other words, the difference between a pilot and an operational system is everything around the model. A key advantage in VFM is auto-adaptation as conditions change. We monitor well tests, compare model estimates to metered performance on test, and adjust automatically. That keeps the estimates aligned with reality without manual babysitting, even as wells age, water cut shifts, and facility constraints move. Optionally, the system can also detect sensor failure or data quality issues and remodel when the behavior changes. That matters because the worst outcome is silent drift, numbers that look clean but gradually stop being true. Failure detection and correction helps keep the operational design honest over time. Confidence bands make uncertainty explicit, so operators know not just the estimate, but how tight the estimate is. Those bands reflect a few practical realities. sensor variance, and data quality. How well the model has matched well-test performance, and the natural variability you see from test to test. When the band widens, it's a signal to investigate. Check the inputs, check sensor health, and, if needed, trigger validation or remodeling. This is one of the simplest ways to build trust. Show what you know and show what you're not sure about, before it becomes an operational surprise. Virtual flow metering supports multiple operational workflows. Production accounting and regulatory reporting benefit from better consistency and fewer surprises. Reservoir management and well performance improve because you have a clearer picture of how much production is coming from where. Surveillance gets earlier detection of changes before they become outages or lost production. And optimization and planning improve because constrained decisions start with better inputs. Across field deployments, the proof points that matter to operators are the ones that persist. Systems that run in production on schedule for years. Deployments onshore, offshore, and unconventional. Models that remain accurate through changing conditions. For example, VFM models sustaining over 90% accuracy for about 10 years on an offshore asset. If you're evaluating VFM for oil and gas, and you want numbers you can operate on, not a pilot that fades, let's talk. I'm Carl Cook at IntelliDynamics. Links and contact details are in the description. Thanks for watching.